Next step in the order when dealing with inequalities is to start looking at compound inequalities. We're going to do an introduction today, as well as look at some more absolute value equations before we start getting more into the transformations piece again. So remember, if you've got the inequality that is greater than or less than, that is, we're going to use an open circle or parenthesis. And now this is new for you, the parenthesis piece. You would use either at that spot, you can use the open circle like you've always learned, or you can use a parenthesis or the other way, depending on which way you need to go to symbolize that open circle. Now if it's an greater than or equal to, less than or equal to, we're going to use a closed circle or a bracket. In that case, closed circle like you've learned in the past, or you can use a square bracket to represent that it's including, which we talked about when we looked at set notation for range and domain in chapter 1. Now, we talk about compound inequalities or a compound statement. That is going to be, and also don't forget, you need to still flip the sign if you multiply or divide by a negative. Compound statement is simply a statement that is made up of more than one equation or inequality. The first type is a disjunction. These are going to be compound statements that use the word or. They're going to be the ones where there's a gap in the middle and they go in opposite directions. So for example, a disjunction statement would be x is less than or equal to -3, or x is greater than 2. We can also write it in set builder notation where we use the funky brackets on the outside, and this reads that x is such that x is less than or equal to 3, and that's a union with x is greater than 2. A conjunction, on the other side, is a compound statement that uses the word and. And that's where it's going to be shaded in between, because it's going to be a situation where it shades both directions and ends up shading the whole line. However, because it says and, we need where it is both for both ones, which is in between. And the set builder notation for this one, if we have x is greater than or equal to -3 and x is less than 2, it would be the set builder notation of x such that x is greater than or equal to -3 intersected with x is -2 or less than 2. And remember, a conjunction is only going to be true if all of its parts are true. And so it can be written as a single statement with x's in between. And we kind of talked about that when we talked about writing range and domain. And so therefore we want to make sure we're careful that we're writing it correctly. The first part we're going to look at is solving and graphing the inequalities. So our first one we have here is x plus 3 is less than 2, or 3x is greater than 9. So we're going to solve these like normal. We would subtract 3 on both sides, and this would give me x is less than 2. Or sorry, not 2, -1. And then on the other side, we have dividing by 3 on both sides, giving me x is greater than 3. So we have that x is less than 1 or x is greater than 3. Sorry, -1. So I'm going to write down -1, 0, 1, 2, 3, because you need to make sure you number your number line. We have an open circle at -1 and an open circle at 3. And then x is less than -1, which means I'm going to highlight this way, and x is greater than 3, which means I am going to go ahead and highlight this direction. Now, the easiest way to remember is because it was an or, we should not be shading in between. The next problem, we have -2x is less than 8, and x minus 3 is less than 2. We're dividing here on both sides by -2. Because we're dividing by a negative, we need to flip that sign, so we have x is greater than -4. And I'm going to go ahead and add 3 on both sides. And that gives me x is less than 5. Now, because these are kind of far apart from each other, I'm going to do -4, -2, 0, 2, 4. And I've got an open circle at -4. And I've got a closed circle at 5, which I'm going to put right out here. And then we're going to get my highlighter. It makes it easier for the shading piece. When we shade this, it would be shaded x is greater than -4, which would shade this way. And then the x is less than 5 is going to shade this way. So in reality it shades all of both directions, but because of the and, we need to make sure that it shades only what is included for both, which falls in the overlap, which is right here. So therefore this would be our solution here on the number line.